Excited. So I think a lot of active engagement, and hopefully we can put on a good demo. Uh, Before I do that, I think there is this ritual that everyone should follow. This is something that's special that only Civo provides, which is praise the demo gods. So I have this mug. I think it's important that everyone who is presenting live demos should have this. So just wanted to give a huge shout out for the branding on that.
I definitely needed one of those. I was like, classic staging build.
Yeah.
I should have had my lucky mug. That's great.
Yeah.
Yeah,
That's
demo
like,
calls happen too. Good luck.
yeah. Perfect. So I think we should be good to get started. Now, I think before we jump into deploying an open source large language model with the help of the Civo Kubernetes cluster, we also talk about the different kind of offerings that are there. I think it's also important to understand that, of course, when it comes to like deploying any kind of workload on top of Kubernetes is complex, right? It's not something that if you know even the basics of HTML, CSS, JavaScript, you can go ahead and do that. Like there is a learning curve involved. You need to learn about things such as basic Linux commands. You need to learn about networking, community networking, operating systems. You need to learn about basic Docker, and then of course the core understanding of how Kubernetes works. And then of course the general way in which you would package together your application will be you have your application code, you create a Docker file, you package that Docker file as a Docker image using Docker build. And then once you have that image, you host it inside of a registry. It could be the Docker hub. And then you simply go ahead and create a Kubernetes cluster. And from there, now you're able to actually serve that image on top of Kubernetes, which is this orchestration tool. So this is a basic primer on what exactly is Kubernetes. And of course, now when it comes to taking a look at these machine learning models, which are these really large scale models that can run easily in sizes of 5 gigabytes and above, depending on the modern day large language models, which can easily cross even tens and hundreds of gigabytes in size, depending on how large their context length is. So you need like really impressive compute, and even the typical Kubernetes pods that you will see usually come with CPUs. So in most instances, if you are trying to deploy these large language models on a cloud instance, you would need to configure your Kubernetes clusters with GPUs. And so we'll also just jump a bit briefly into how that actually works before we actually kick off the demo. Now, a fun thing that we'll also do today is I will be using Pieces Copilot, for which I have already turned on the live context. Now, what I did was that I really enjoyed this particular article, and everyone who just wants to actually get started with using Civo and you want to deploy your first ever Kubernetes cluster, definitely take a look at this particular blog, which is deploy your first Kubernetes application through the CLI. And again, as the way that the live context will work is that as you are doing anything important on your device, the Pieces OS will be able to capture the most important parts of your workflow, so through screenshots, and then it will intelligently understand what exactly are the most important bits, and then you can actually query that through the live context feature on the Pieces Copilot. So what I did was that before this, I made it kind of, I was, just going through this particular blog myself, which kind of covers, you need, of course, kubectl in order to, run your Kubernetes cluster locally. So for example, if you want to create a cluster on Civo Cloud, so first thing you'll do is you'll go to civo.com, you will sign up for the account and you'll create a cluster. And then you'll also have to download kubectl locally, and using which now you will download your kubeconfig file and you will set it inside of your local CLI. And then, of course, there are primarily 3 different things that you need, which is a deployment file, which basically means what kind of container image you're going to be using. So it will go ahead and deploy that on a particular Kubernetes pod. And then you would basically have the service. So that's the backend. And then finally, you'll have a deployment file and ingress. So ingress will be for setting up your networking and deployment, so that now you can actually host it on, let's say, using a load balancer, you will have an actual endpoint which you can now hit, which is being served on this Kubernetes cluster. So I found this to be really helpful. So I can actually go ahead and just, ask a prompt, which is summarize the, and I can perhaps, just copy this particular URL or the name of the blog, summarize the blog that I was just reading in Chrome, which can give me more details into, and again, given the fact that right now I'm using the GPT-4o model, you can also use any of the local large language models that you might want to use. So then, it will take some time. And as you can see that it is able to understand that it is on civo.com. So it is able to capture all of the important information. And I had a separate conversation where, then I also asked it, can you share each of the steps focusing on the deployment, service, and the ingress file? So that's a basic gist of how, you can leverage Pieces Copilot with the live context feature. And we'll also dive deeper into when we go into the hands-on. Now, what I'll go ahead and do is I have a few slides that I want to kind of put together, right? Now, typically, the way that you are actually running these machine learning models is through CPUs, and of course, GPUs if you are running more compute-intensive tasks. And you might also use TPUs for more specialized models like the Gemini and the Llama models from Google. They work particularly well on tensor processor units. And primarily, just to understand this on use cases, that typically whenever you are setting up any Kubernetes cluster, it will only have CPU support by default. So whenever you are integrating GPU support for Kubernetes, and we will also have a small demo where we'll show you how you actually set up the operator for, let's say, an NVIDIA-based GPU on top of a Kubernetes cluster. So we'll handle that very shortly. So in that case, there are primarily the two different things. One is the host level components. These are essentially what the GPU is providing to you, which is basically the NVIDIA container toolkit and NVIDIA GPU driver if you're using NVIDIA-based GPUs. And then on the Kubernetes side of things, you'll actually need a couple of things, which is the Kubernetes device plugin, which will be able to actually find or locate the actual GPU device itself that's sitting somewhere in your entire cloud cluster. And it will be able to discover that, right? And then you'll be able to leverage, like, let's say you'll be able to connect the GPU inside of a particular node where you can now define in your YAML, which kind of looks like this, where, for example, if you want to see, what you essentially do is that within the YAML file that you define when setting up your Kubernetes cluster or defining your cluster, you will define that inside of the containers, and specifically you'll share based on whether it's NVIDIA or AMD, you'll provide the image name. So in this case, if you're using NVIDIA, you're using NVIDIA CUDA, and then you'll define how many, you can define how many GPUs you actually need. So depending on how big your use cases or how complex your workflow is, you can either define one or two GPUs or even more, depending on how large your Kubernetes cluster is. So that's the typical way. Now, of course, when you're basically setting up Kubernetes cluster with the GPU config, you essentially need to install the GPU operator on top of the Kubernetes cluster. And in case you're using the NVIDIA side of things, then you have to basically install the NVIDIA drivers, which will basically have the NVIDIA container toolkit. And in order to verify that, yes, it has successfully been installed, you'll use the SMI, NVIDIA SMI, to just confirm whether the cluster or the node inside of a Kubernetes cluster actually has successfully installed the NVIDIA operator. So in this case, the way that we'll basically do it inside of the Civo cluster is we do have this repository provided to us, which is basically a Civo GPU operator Terraform file. So this essentially has Terraform config. For those of you who might not know, Terraform is essentially infrastructure as code. So it is a way to basically deploy or automate the deployment of your DevOps architecture. So whether it's your Kubernetes clusters, your Docker or ECS, EKS instances, right? All of those, or in this case with Civo, where you want to deploy your load balancers, all of that can be automated with the help of Terraform. So what we'll do is, before we actually jump into the live coding of setting up this GPU operator on top of Civo, I'll also just quickly go into my Civo UI. So I'll just quickly go ahead and open my dashboard. So here what you can see is primarily, as Kunal also kind of showcased, that we typically, the way that if you want to set up either a GPU-based Kubernetes cluster, so we have the section of the NVIDIA GPUs. So you can actually set up a standalone NVIDIA-based VM, which will have a GPU cluster. Or if you want to set up a GPU-based Kubernetes cluster, you can also set that up. So if you want to do either of these two, you can go ahead and manually do that as well, where you can select based on the GPU. So you'll have the ability to select, a GPU-based cluster. You can also select a normal CPU-based cluster as well, and go through this manual route where it will basically create the cluster for you. But of course, one thing that to keep in mind is that at this very moment, whenever you actually create a GPU-based cluster on Civo, you cannot. It does not come pre-configured with the GPU operator. So NVIDIA operator does not come pre-configured. That is why we have this GitHub repository for the Civo GPU operator Terraform file, which will automatically not only create a GPU-based cluster on top of Civo Cloud, but it will also actually handle this basically setting up of the NVIDIA GPU operator on top of the cluster, so that now you can leverage it inside of deploying your any kind of workload that requires use for an GPU. So what I've already done is I've created this code space that is already up and running, and we'll just follow the particular steps that are given right now, because this is something to keep in mind if you are planning to use the GPU-based cluster. So I just wanted to kind of spend like the first 5 minutes talking about this, and then we'll jump into actually deploying the we'll actually deploy the Llama 3 model on top of the same GPU cluster. So in order to basically do anything when it comes to using the CLI for Civo Cloud, you need to actually set up an API key, which you can go and find inside of your settings. So if you go over to your settings in your profile and you go to security, you can easily just set up an API key. So I'll just go ahead and click on the existing API key, and you can set up your own when you sign up. And you also do get free, I think $250 credits on Civo Cloud whenever you sign up for the first time. So even you can actually set up and try out the same demo that we are running today based on your use case. So as the kind of, the README kind of suggests, so the first thing is that we'll create a new file. And over here, let me go ahead and create this new file, which will be the terraform.tf-vars. So this is important to basically set up in so that you can use this particular token when you are actually setting up your cluster. So I'll just quickly go ahead and configure this over here. So I'll just copy this over. So as you can see that now we are good to go on this side. Now what we have to do is that we also actually need to install Terraform. So I believe that I might not have Terraform. So we'll just go to the HashiCorp guide on installing Terraform. So we'll just quickly install Terraform over here inside of, I think it's since this is an Ubuntu cluster, let's go ahead and install this inside of Linux. So let's just go ahead and copy these steps. So Terraform, of course, as I mentioned, is required for you to use the infrastructure as code automation to deploy those clusters and not have to manually work on getting things such as your networking, all of that, because all of that can be a bit tricky. And even if you make one mistake, then debugging all of that can be a bit difficult. But that's where you can actually leverage Pieces Copilot, because that will not only be able to actually see your code, but also be able to, if you're using the live context, it will be able to see the exact error that you're actually getting. And using that, you'll be able to get the entire context of both your code and the error that you have. And that way, it will just make it super easy to run across. So let's just quickly finish these steps in order to get Terraform installed on our cluster. So I think we should be good to go. And if I run the final command, we should have Terraform up and running. So we should probably just have another couple of seconds. All right, perfect. So we have, I think we have Terraform installed. Perfect. So now what we just have to do is we have to go into the infra directory, into the TF folder. So this is where now, so typically what ends up happening is that whenever you wish to use Terraform, you have to basically first initialize Terraform. That will also install all of the relevant providers. So in this case, I'll just go ahead and do Terraform init for to initialize Terraform inside of my project. And then when we basically use Terraform plan, it will see what all resources that actually need to be created. Or if you have already actually used Terraform in the first place and you have deployed your resources, then you can also still use the same Terraform plan, because it will be able to understand that if you have already deployed certain resources, it will just automatically update them. So it will not create new resources unless you specify it to actually do it. So once we have initialized, we should go ahead and use the Terraform plan. And here we'll just simply again post our Civo token that we have just created. And this will go ahead and now just plan out what all resources actually need to be deployed. And finally, what we'll go ahead and do is we will do a Terraform apply. So this is what will go ahead and actually deploy our resources. So again, this can usually take around anywhere from and I'll just go ahead and say yes. So since this is actually creating the actual clusters, it can take anywhere typically between 5 to 10 minutes. So the reason that it actually failed was that I already had created this background, because of course we have a limited amount of time. So I had already deployed this particular cluster right over here. So as you can see that when you actually deploy the cluster, it will show you that it has successfully deployed. So you'll get all of the resources. And just to kind of show you what all things we are actually deploying, so we have a bunch of tests running. We have the network, we have the firewall, the actual Kubernetes cluster itself, and the GPU operators, all of those, right? So if I go back into my Kubernetes section within my Civo cluster, perhaps I think I had deployed in the London region, I should have my GPU cluster operator Civo. So this is the one which got deployed, and I just deployed it like half an hour ago. And so that's one thing to keep in mind, that this is how you would basically set up a base cluster with the support for GPU, because that is something that is important to keep in mind whenever you are deploying or you're leveraging a GPU-based Kubernetes cluster with the help of Civo. Now, let's get into the fun stuff, which is basically going to be deploying an actual cluster. So the thing over here is that once you have basically configured your Kubernetes cluster with a GPU, so of course you need to basically have a YAML file. So there are multiple ways that you can actually go about deploying a project on top of the Kubernetes cluster. So you could basically have an app, which is a Python app that will have your source code with the large language model of your choice and with the actual endpoint. And then you can, as I mentioned earlier, basically containerize this using Docker. So first you'll create the Docker image, then containerize it, and then deploy it on top of Kubernetes. Or the other way is that you could also define, if you already have an existing image with you, so like a Docker image, you can just directly define that inside of a Kubernetes manifest file, which essentially contains of both the deployment and the service file. So these are used for actually deploying and then being able to actually host it on a particular port. So for instance, within the pieces, you get this really nice feature of saved snippets. So if you're like, let's say, navigating through different docs websites, if you are, perhaps going through, I guess, Kubernetes docs, right? So I could be going through the Kubernetes docs, and perhaps I find this really important code snippet during while using the CLI. So I can very easily, what I can do is I can use basically the PWE, which is the Pieces web extension, and save code snippets out of the box. And for instance, when you're doing a lot of deployments with the help of Kubernetes, you might need certain, basically some pre-configured YAMLs that you might have to actually use every time you deploy a new Civo cluster. So very easily, you can go ahead and use the Pieces web extension. I think I actually didn't have that installed, but I think that will be good to have it installed again in this particular browser. So if you want to install, you can install it for Chrome or whatever browser that you need. So in this case, I'll quickly go ahead and install it for Chrome. So I'll just quickly go ahead and add it to Chrome.
Yeah, Shivey, I will say when I'm doing configs, I mean, that's probably the number one thing I save to Pieces. Yeah. And like, it's so crazy the amount of time where I'm like, where did I get that config from? What site was it on? Things like that. I mean, YAML, like my Pieces is like filled with so much YAML and like so much JSON. It's wild.
Exactly.
Nice.
And again, that's something to keep in mind, that especially if you're a DevOps engineer, right? If you're and of course, live demo, we'll have the updates coming up. So that's always fun. So hopefully we should have this running. Okay, perfect.
No worries, no stress.
Yeah. All right. So
and then these are just pro tips, because if you have as many tabs as I have open and as Civo has open, like it's just nice to be able to fire and forget. Exactly. I will say that.
So once you basically have pieces installed, right? What you can do is, I think I was here at this documentation. I think I should go back to this. Oh yeah. So for example, now if I want to save this, I can just quickly go ahead and click on Pieces Copilot and save this particular snippet to Pieces. And now if I go back to my, to my pieces over here, you can see that I just had this same snippet that I had found on the website. And now I can simply go ahead and copy this over and reuse this inside of my VS Code or any other extension that I'm actually using. So similar to this, I had already created a snippet specifically for being able to actually deploy a Llama 3 model. So here is an example of how a standard Kubernetes manifest file would basically look like. So there are essentially two different components to it. The first one is this deployment component. And over here, what you'll see is that we can define whether the YAML is actually a deployment YAML file or a service-based YAML file. So deployment over here, as you can see, is that it will deploy this particular container with this image. So this is deploying the Civo Docker image that will be actually hosting the Llama 3 model. So in this, I have the environment file. And over here, we have also actually defined the GPU that you'll be using, right? And similarly, we have a second one, which is the service file that's specifically for deploying this as service. So in this case, for example, if you're running your application as a Flask application, so typically a Flask application will be served on the port 5000. So you can very easily go ahead and serve this on that particular port, whichever port you want to define it on. So this way, if you have your these code snippets saved, now it actually saves you so much amount of time, not having to go back to the Kubernetes documentation or for instance like Civo documentation and clicking and copying that that particular snippet, because YAMLs, as a DevOps engineer, you're essentially dealing with day in, day out, right? Most of the work is actually using these YAML files, and these can go crazily complex. So this one is just
yeah, Civo, I was gonna say two things. Click on the origin site in the context preview, because for me it's the snippet represents a part, and then I'm okay, it might be in your other window.
Oh yeah, that might be, I guess I can copy it.
No worries. You can go to the gallery view and try that.
Oh yeah,
there you go. But yeah, it's okay, where did this snippet come from, right? And then kick out to that original repo, kind of go through the larger docs at hand. But it's okay, I know I'm looking for this type of YAML. And the other thing too is, this is my favorite, is search by snippet. So when I'm using JSON or YAML or whatever else, you can go to global search and copy a bit of that YAML. So yeah, you could do it like that. But my favorite is copy some of the YAML. Yep. And then go over to global search real quick. In your drop down. So the drop down at the top where you go to the Copilot.
Oh yeah, the global search.
Global search. Yeah. And then click the drop down right there. So it's that one, search by snippet. Now you paste that YAML, and now you can kind of see everything that is even remotely related to that config. So really nice way to say, hey, I know it's related to these keys or these setups or whatever. I'm going to go paste that and then find the actual larger config in Pieces, which is pretty cool. And then kick out to the repo and backtrack.
And as you can see, that this is basically the the snippet that I had saved, and it can directly go to the source as well. So I mean, if you're kind of deep linking in this way, I think it just makes it super easy for you to be able to search for those really pesky large YAML files. So as a DevOps engineer, I think this is a super useful tool to be able to augment your, because I know when you are deploying, even if you have one small mistake in your YAML file, for example, the load balancer did not deploy correctly. So that can take 15-20 minutes at least to just try to debug what might have been the issue. But if you have your pre-configured YAMLs, it's very easy to search for them. So yeah.
Awesome.
Anything else that you wanted to add to that, Civo?
No, I was just saying awesome. I mean, really, really great. I'm pretty excited about the large language model deployment here.
Yeah. So far, we have been giving you kind of a preview of what it's required to basically, first of all, set up a cluster on Civo, set up the GPU, and then of course now technically what you can also do is you can take this YAML file which I have over here in my save snippets. So you could essentially just copy this over, have like, let's say, save this inside of something like a manifest.yaml file and use kubectl -f and then apply, and then this particular manifest file, and it will automatically take care of deploying that. But of course, we just for the time's sake, you can actually also again automate this with the help of Terraform again. So in this case, we have this particular repository which you can quickly go ahead and clone as well, and we'll be sharing the resources with everyone. So here, what we have is basically a template for you to kind of cover. So the idea here is that we, for example, if you have a complex app such as, where you will have a main file with that's going to be deploying a Llama 3 model, and in this case, this particular demo will actually have two things. So it will have a UI where it's like a ChatGPT based UI. So it's an open source client which is similar to ChatGPT, and then you can actually run any type of large language model that you wish to actually deploy. So in this case, what you just have to do is, if you have this particular repository, you just simply go ahead and I'll go ahead and click over here, and I'll basically go ahead and create a new code space for me to quickly go ahead and run this over here. And I'll just quickly go over, how to again set it up. So basic setup is again fairly simple. We are essentially again going to be using a GPU based cluster from Civo. So if you already have your Civo based, and I'll go back to my settings over here and grab my Civo API key, which is required for this particular demo. So in this case, again, the similar thing that you need is whenever you're setting up the Terraform, you need to be able to create the terraform.tf-vars file. So I'll go ahead and quickly do that. So I'll use the terraform.tf-vars file, and I'll simply do the same thing that we did before, which is just quickly save this particular secret right over here, and I'll just replace this. All right, perfect. And now there are two things. So of course we have just to kind of show you what we are actually going to be deploying. So this is basically the new chat. This is again deployed via the Civo cluster. So I have the Civo cluster already running over here, which is this LLM boilerplate, because just so that in case the demo fails for some reason, we have the backup already running. But just to kind of show you like what exactly we are going to be deploying. So it's essentially the application has two parts. We have the actual large language model getting deployed on top of a GPU cluster. But we also have this web UI that is being served. And this is the actual web UI that you can actually see. So in this case, what you might see is that surprisingly, this is a UI that's very similar to a ChatGPT-like interface. So this is, I think, as far as I remember, it's called as Open Web UI, which is completely open source, by the way, and you can deploy it, self-deploy it. So everything that we are using right now is completely open source, including Llama 3 as the LLM that we are going to be deploying. And as you can see that you can actually select between different type of models. So if you were to change your config to use some other model, you can very easily just have the container image of that particular model and just replace it, swap it, or even add more models if you wanted to quickly switch between different models. So this is the UI, and I can interact with it. I can ask it who built you, let's say, and just kind of confirm that that it was actually built by Meta AI. So you can actually see that it is running completely fine. And if I go into the actual cluster itself, it already took care of setting up the load balancer, which you can find over here. So this is the public URL of this deployed web UI, which is the open web UI, which is connected with this Llama 3 model, which is running. So this is the deployed link on this public UI. So this is the demo that we are actually going to be deploying. So now there are two ways. We have our actual code inside of our app.py, where what you'll see is that we have this particular route where the first thing is that we have Llama, which is another open source tool that can run local large language models. But one limitation of Llama, of course, is that it is just a tool to actually run local large language models. But what you get with the capability of Pieces Copilot, being able to run it locally and have support for models like Llama 2, is that you have that entire ecosystem experience where you can very easily plug it in with your VS Code extension or any other extension for that matter, and with the desktop app. And we are also bringing in support for Llama 3 and Gemini models as part of our product hunt launch. So super excited for that. And probably, Civo can talk more about that in a bit once we conclude the demo. So we are basically having Llama actually serve the Llama 3 model. So what we'll do is that it will download the artifacts of Llama 3 from Hugging Face. And there are different types of Llama 3 models with different context sizes. So depending on whichever you want to use. So what it'll do is that on the actual Kubernetes cluster, it will run the Llama on this particular endpoint, serving the Llama 3 model. So it just helps you to serve that particular Llama 3 model. And at the same time, we're also actually going to be running the OpenAI. So that's where we are using that. And then we also have a Docker file, which you can see that if you were to just go ahead and navigate to this particular file, you just have to go ahead and simply Dockerize or containerize your app.py file. So it will create the Docker file, and then you can actually just run it using python main.py, which will serve not just the Llama, but also it will serve the open web UI, which you are basically running. And you can see all of the requirements.txt file. So that's the thing with respect to the actual application code. So this is what will basically serve your application. And we also have some notebooks that are primarily for capturing OpenAI, which will be used for. So over here, what we're doing is that whenever you're actually sending a prompt to the actual application code, in this case, which we are basically doing it over here. So we are using LangChain. So LangChain is a really nice way for being able to interface with your large language models. So whether you want to create prompts or you want to actually create like entire retrieval augmented generation based chains. So LangChain actually allows you to do that. So all of those things behind the scenes, which are basically powering this UI application that you see, are being handled by that particular file. So again, simply what we'll do is we can either use the infra repository. So here what you'll see is that we have the Helm chart, which will be actually used to deploy our cluster. So here what you'll see is this is the deployment .yaml file, and we have the Helm chart that will be actually used to deploy it. And then we also have the LLM boilerplate code repository that will be used to actually go ahead and take all of the code that we have within this. So in this case, all of the Terraform files that you see. So in this case, we have the different TF files for deploying the Kubernetes cluster, the firewall, the network, the Llama UI, which you're seeing, which is the open web UI, and the actual like the Llama 3 model, where what we are essentially doing is that we are basically capturing the Llama 3 model that's deployed on top of Hugging Face, and then we are simply just pulling that particular image and deploying it. So let's go ahead and now we have set up our Terraform. We have set up our Terraform.tf file. Now we'll simply go ahead and go to our infra directory and go to our TF directory over here, and simply again just use Terraform. So I think in this case also I don't have Terraform installed, but basically the steps are essentially the same, that you use Terraform inet, Terraform plan, and apply it. So it will basically deploy the entire cluster. And the way that it will, again, this might take up to 15 minutes, and since we are short on time, I'll just quickly show you how that actually looks like. So I'll just quickly go ahead and probably start this Terraform, start this code space again. But the idea is that you just have to let the Terraform do its magic for you, and it will take care of deploying everything from setting up the GPU cluster and also setting up everything in between. And once you're done, so basically that is where you'll be able to see that also the load balancers automatically have been set up for you, the persistent volumes, all of those, and the firewall rules and the networking, the networks, all of them have been set up automatically with the help of the Terraform files that we just deployed. And the configuration of what these kind of look like, so all of those are actually typically defined inside of the variables.tf file over here. So in this case, for instance, like, this is the example where you see that, all of before, again, those particular code spaces were active for quite a while, so they got reconnected. But the idea is that all of the files for the names of the actual cluster itself are defined in the variables.tf file. So for example, if you want to also then run some tests with your application, all of those will be present over here, including the deployment of the NVIDIA device plugin for adding the support for the GPU, right? So all of those are defined within this variables.tf file. So if you were to change the name of your GPU file, your cluster, you can directly go ahead and change this particular name. So we have some default values that have been set, as you can see. So if you were to change them, you can simply go ahead and change that config. And finally, what you see is that you have this entire cluster, GPU cluster, that's not only serving the actual Llama instance that is running the Llama 3 model, but is also running this web UI, which is being again connected with the Llama 3, which is now a deployable links. If all of you were to test it out, I think I'll keep it running for a short while, so you can simply go ahead and run this if you're interested. But that is a quick, yeah.
Civo, I was just going to add, wanted to take a quick moment to just appreciate the developer experience that kind of comes with the Civo Cloud console and Terraform. It seems like, between the two tools, it seems like a very powerful type of developer flow, right? And I think, when you get into DevX, that really makes a difference. Managing these load balancers, like even trying to find a public IP address in Azure or Google Cloud or Amazon can be hard, right? And so I love how it's just like presented, because the whole time I'm thinking here, like, this is how I've done it on other platforms, and it's just so well composed. And I also like the developer docs that you showed us with the kind of pre-built examples and everything. Super robust, super easy to follow. Yeah.
And I think like this is where what I can probably do is, if I have pieces running right now locally, let me go ahead and open up. Yeah, perfect. So I can also always go back to Copilot, because I have the live context set up. So, I can perhaps, let's say I was editing that TF variable. So I can always now give a prompt to the Pieces Copilot with the live context, because as I was doing all of that demo, it had all of that context. So for example, if you were to now replicate that same demo, I can ask it, what were the steps, let's say, in order to run the name of the file, or we can probably try this out, live, because we love live demos. So hopefully this should be able to capture that. But I can probably ask it, what are the steps involved in, using Terraform for the Civo Llama 3, or I guess Llama Llama 3 project I was trying to deploy. So again, this gives you the power, because considering that, when you're using something like Terraform, and if you're not new, if you're new to it, right, so you might not be aware of all the steps. So hopefully, as we were able to, as the live context was actually capturing all of the important bits of information that we were doing while we were busy with our deployment, it was capturing all of those important context information. So she should be able to answer that.
That's a really advanced question. I will be shocked if it gets this with your staging build, but wow.
There you go.
Oh my gosh, that's wild. I see right there, list, plan, deploy. It got the CDs that you were doing.
In fact, like, it also gave me important information on, like, for instance, these 3 steps were basically if I were to deploy directly using the Terraform, but it also provided me additional context into that. Okay, because if you remember right, I first showed you that app directory where the actual source code is. So what the Terraform is actually doing is that it is capturing the pre-configured Docker file, Docker image that we already have on Docker Hub, right? But if you had a custom code, if you had a custom source code, like for example, you were not using the open web UI, you're using some other front end, like a Next.js front end. So you wanted to deploy your file, right? So first you'll have to actually build that image and then push it, and then go ahead and actually run your infra to be able to capture.
Yeah. Yeah, and it's pretty wild how it all orchestrates together. Kunal, I just saw that question that you threw up there about costs, you know, around training, quantization, things like that.